Dear viewers, today I want to show you complete steel warehouse modeling, analysis and design in Staadpro Advanced Connect edition. So we start by launching Staadpro Advanced Connect. Then we're going to create a new model. I will call it Ashland. Edited. You can save it in whichever location. Then check your license. Okay, you can just accept. Configuration. My unit, I want to use English, not metric. Global axis, Y up. Design code can change from here. I want to design in AISC 360/16. That is steel. And then okay. So you can also ensure that you are using the correct units from here. Then I will use analytical and then create model. So you can add some job information, job name, Ashland, etc, client. So just create. I usually prefer to model using nodes. So here is my architectural. So I'll model using these nodes. And let me just turn off some layers so that you can clearly see. Enter. We'll also turn off this. So this distance column to column is 20, 20, 20, and then 25. And then this way is 20 feet on center. So I will just add new node at 0, 0. And then I can just select my node cursor, select that node, and then I want to do translational repeat. How many times? 1, 2, 3, 4, 5, 6. Each 20 in the Z direction, 20 feet apart. So I'll go to transitional repeat in the Z direction and 20 feet, and then 6, so that the total will be 121, 2, 3, 4, 5, 6. Then click OK. I want to do transitional repeat for these grid J and A 23 times. This one is already selected. I'll select this one in the X direction. X 20 feet 3 times, number of 3 steps, then click OK. We can select now this one. Now we are going to do transition repeat 25 feet 4 times, 1, 2, 4 steps, 1, 2, 3, 4. In the X direction, 25 feet 4 steps in the X direction, and then repeat 3 steps, 20 feet. In the X direction. 3 steps. Now we can copy this one, this intermediary, by just holding Control. Then I want to do transition repeat. We can instead of that, copy or this one. I can do transitional repeat in the Z, 20 feet. Instead of 6 times, we say 5 times, and then OK. Now, because I've picked this side, and you can see the axis, the Z direction is this way, we're going to select negative here. Because if you pick this side, then you'll be moving in the positive direction. Okay. So the next step is I'll do transition repeat in the Y direction. Now this height is 16 feet. So transition repeat Y 16 and then link steps. Okay, we need to determine the distance. We need to model this hip roof. Therefore, to do so, I will just scale this drawing. Can just scale it. I know the distance from here, that end, using my reference from this end to that end is 20 feet. Now, we need to make sure that we are change the working unit for length. So type DWG units, select it, DWG units. If I expand here, you can notice that we are working in 3, which is millimeters. We need to change that to feet, that is 2, then hit enter. Okay, yes. So if I now type again, can just zoom, type Z, then extend. Now I don't need these ones here. Zoom again, extend, so select extend. Okay. If I type DWG, we're now units. We're now working in feet. The next thing, I will type dim style, DIM style, then select dim style. I can modify. I only want to modify the primary units from decimal to architectural, and then make sure my precision is that one, and then click OK. then close. Now I want to scale this one about this point using reference. So I'll pick reference from that point, make sure this one is 90, and then that length should be 16, or rather 20 feet. So hit enter. So 20 multiplied by 12 should give me around change feet to inches. 20 multiplied by 12 should be 240. So this one will be 240. Hit enter. Now let me check. You can see now this one is 20 feet as intended. So because I have this problem, let me just scale everything. Undo the changes, then I can scale all these. That everything will be to scale. So scale from this point using reference, that point, then 240. Okay, now if I change the dim style again, the symbol, this one I'll increase it to 200, text 200, and click OK. I hope this one is not too big. From this point to that point should be 20 feet. Now we can easily determine this height from that point. That point is about 34 feet 8 inches. So if I go to my plan, you'll notice that this one is 8, grid F and D is 8 feet apart. It means that if this distance from here to here is 120 and this one is 8 feet apart, that one should be, using our calculator, one should be 120 feet. 120 feet minus 8 feet should give us 112 feet divided by 2, 56 feet. So at these, from this one, from this, the third, from 1 to the third node to the other node from this side, so I will move them 56. So I'm already selected node cursor. All these nodes, I'm holding control, then I will do transitional repeat in the Z negative 56. And then hit OK. Again, from this side transitional repeat. Now in the positive Z 56. Okay, now these nodes, I just select all of them, and then transition repeat a distance of 34 feet 8 inches. 34 feet 8 inches should be about around is it 2 thirds 0.75 8 divided by 12 should be 2 all over 3. Okay, so I will move the Y 34.3333. I will add beam from this point, that point, this is that point, from that point to that point. One, two, three. So this one, console, right click, select cursor, beam cursor. I'll delete that beam, okay, and that beam. No, so I'm not deleting the node. From that, 1, 2, 3, from this. Okay. Add beam from this one to that point, and finally that point. Okay. We can select again beam cursor, this one and this one. I want to do transition repeat in the X -20 3 times. Okay, we are going to remove this one. We're going to delete, yes, delete the orphan nodes. Okay, I will draw another beam, this hip to that point, that hip, that point. Again, select beam cursor. I will select this one and this one. Transitional repeat in the X20. This time 2 times, because as you noticed 3 is too much, so I will just Again, I can click, pick that one, holding control on that one, insert node at midpoint, click OK. Then I think this one is the midpoint, so that one, the 1, 2, the third, no, so, and just right click, I'll go to select and then pick cursor, beam cursor, and select everything. We want to go to geometry and then we want to select this one, intersect beams. Okay, 16 new members have been created, so it means we can just delete that and that. Delete. Okay, yes, delete those open nodes. I will pick now this one, transition repeat in the Z, 22 times. Again, transition repeat in the Z, -20, 2 times. Right, select everything. I'm not sure if these ones will be intersecting because I think they will intersect. So let's intersect selected. Okay, 16. Okay, they have intersected, and just delete that one. Yes, just select all these and then click that X to delete. Yes, delete the open nodes. I will add beam from that point to that point, that point, that point, and then I will intersect. Select beam cursor, or you can right click and select and then intersect. Click intersect selected beams, and then okay, those new beams have been created. We can come to utilities, then nodes, remove open nodes. Okay, so after that we can go to we can do our bracing, because without bracing obviously these ones will fail. So I will do my bracing, just selecting, Where do I need my bracing? Doing some of these points here, or here and here. Just select all of these. Insert nodes. At endpoints, I want 2 points. Then I will add my bracing. No. Now before we go further, we can just go to our properties and then add section database. I want to add some tampered section. So we're not going to use the normal database. I just go to tampered. I will change my material here to steel 36. My F1, my start will be 24. My F2 will be 10. My F3 will be 48. Is it too much? 48. Now we're using feet, right? So this one 48 divided by 12, because these are inches. 48 divided by 12 should be 4. Here should be 2. It's going to be 10 divided by 12. Divided by 12. 0.83383. 0.83. F5 2 2 inches. 2 inches will be 2/12. 2/12. 0.17. F6 F4 F2. So F2 and F4 F2 should be 0.17. F6 0.83 and F7 0.17. Hard. Add it. So we can just add a new F1 2 F2.17. So this one F3 will be 4. F4 will be 0.83. F5 will be 0.17. F6 now this one I prefer it to be not 4 but 2, and F7.17. Add. We can just edit, change this material to that, change. Tamper. The next tamper will be F1 will be 4. F2 will be 0.17. F3 will be 2. F4 0.83. F5 0.17. F6 0.83 and F7.17. Then material is this one, then add. We need to save this model, save as, then save. Okay. And go back. Go to view, that view, right click, select node cursor. So we need to add support. Pinned. Then add. I'll pick support 2 and select. Then assign, yes. Then we can save. We can go to view, that view. Right click and then select beam cursor. Go to I want to go to properties, temper on. Assign, yes. Okay, that's a good part of saving our model, because Staadpro, my version usually behave like that. So we just find it here. Here is it, Ashland. Associate. I will start with my columns. My columns for F1 was 2 feet, F2 was 0.17, F3 was 4, F4 was wind of top flange was 0.83, F5 was 0.17. Excuse me. F7, F6 was 0.83 and F7 was 0.17, and material was, then add, then and go to this view. From this point we will be saving each time. So I want to select beam, not blade cursor, and assign to the selected beam, yes. Now if I go to, let me first save. If I go to rendered view, okay, I want something like this. Apart from some of these, I want to change the rotation. For this one, I want the rotation to be a 90. So I will go back to that view, and then I want to go to beta, click beta angle, right angle, or we can just do angle in degrees 90. Then I will select, then select all these, then assign. Then we can go to file and save. If I go to rendered, this is what I want. I want them to be like that. If I now go to everything, you can see. Now the other problem is, if you notice, this one I want to rotate this by 45 at the corners. So I will create a new angle, 45. Okay. Then can just go to that view, pick, right click. I want to select, I want to make sure you add beam cursor, pick those, holding control and check that, and then assign yes, and then we can save. If I go to rendered view, that is all. That is what we want. Now if you notice, these two are okay, while this one, the orientation is wrong. So I will create new angle. Is it 45? Is 45 going that way? On that 5, let's say on that 5. Okay, then I will pick this one and this one and assign on that 5. Assign the selected beam, because it's just 45 times 3. If I go to rendered view and realize these ones are okay, so they are all okay, and then we can again save our model. These two, I will go to select. I will want to go to nodes and then insert nodes by n2, because I want to divide it into 3. Okay, so I'll go to geometry, all properties, add new taper. Let me check. This time we're going to start with 4. Web thickness of 2, it is 0.17. F3 2, F4 0.83, F5 will be 0.17, F6 will be 0.83, because I'm working in feet, F7 will be 0.17. Material, obviously steel K36. I want to pick all those, including these ones. And I will assign. Yes. Save. All these. Just pick the first again. So I forgot to unselect. All those columns were selected. Okay. We will have to change those. I will assign. Yes. Now if I go to view, unfortunately we have done some changes to our columns, or are they still the way we intend? I think yes. Yes, they are okay. We will add a new, just save before, because we don't want to repeat that process. I'll go to properties. And then taper. This time I want same material, 2 feet at F1. Web thickness, what is F2.83. F3 2 feet. F4 will be F4 will be 0.83. F5 0.17. F6 0.83. F2 0.17, unfortunately, and then F7 point, unfortunately made that mistake, then add. I will pick all these. Assign, yes. We go to rendered view. Then we need to assign this one. Then assign. Yes. So I go now to those. So we can now save again. Save. Then this one we can assign this. And then save. I'll add new property. From section database. Let me view table. I want, is there any road? There's no profile for this. So to add profile, we can just use the same material. So I'll go to select missing property. I'll select by parallel. Parallel to X. Then parallel to Z. Yes. Okay. I can select by missing properties. And select all of these. assign, yes, select. Okay, so I'll go to new section. I want to add my, let me select first by using property, geometry, mirror, about yx, xy. I will pick node because you can see yx, that node. It has been mirrored to the other side. This one you can divide it. Insert node at a midpoint. Okay. Right click. I want to select node cursor. The two nodes. Okay, we did not divide this other side. Beam cursor. Insert node at midpoint. Right click. Node cursor. The same thing here. Then I want to do transition repeat in the Z direction, -20. And then can add beam. Just undo. And then right click again, beam. This one I will insert node at midpoint. Add beam. Or we can just go to select beam cursor, holding control. And then we want to mirror about y. This is the y axis is going this way and x axis going this way. So xy, I will pick node, this midpoint here, and then click OK. Save. Can insert new section. Whole section round. If you view from table, you can see the diameter. I prefer a diameter of about 6, so this section number 59, so 6, then material, add, then select by missing properties, assign, yes, and then you can go to specification for beam. I will add release, partial release, MPZ 0.99. And then beam and partial release MPZ 0.99 for my bracing, add, then assign, yes. We can go to loadings. We're going to define wind, add, wind 1, add. My exposure is 1, add, and then assign to view, assign, yes. So we need to edit this one. Wind add, just delete, add, basic wind speed, let's say 95 mph. Structure, for building structure, apply, main building data. My height is 40, okay. My length is 220 and 120. Partially enclosed, apply. Leeward, side walls. Okay. My intensity factor is 1. Assign to view, assign, yes. I will add CSMIC, add. I can use IBC 2015. Maybe a period of 1. But you need to be careful when you're editing the data in this. SS, S1, side class, prepare, or depending on design criteria, you need to be careful in the way you fill this data. Then after that, I'll go to self weight, add So I use just UBC. Self weight one add. You don't need to state the direction. I'll go to load cases, add my dead load. I'll start with self weight. Dead load. Live load. You need to be careful because as long as the CSMIC load in Staadpro, you must start with CSMIC. So I will add starting with CSMIC EQ Z or X EQ Z dead. Start with self weight SW dead load or we don't need this one. Live load, so you can go to roof live and wind load. X wind load Z. So for this, add just self weight, then assign to view. For this, add just self weight, then assign to view. For dead load, add self weight, add assign to view. You can add member. Now I will go to plates. Or instead of doing that, we can just I'll go to view. I want to selected view. selected view. We can just rotate this one. Selected objects again, and then we need to determine, let's say we're having a roof dead load of 1 PSF or of 10 pound per square foot, that is PSF. So if I go to member, loading, or if I go to dead load, add, I want to go to member load. It is in kilopound per square foot in the globe Y. Okay, so let's say we're having a dead load of 10 PSF for our roof. That should be 10 PSF. To change to kilopound, you divide by 1,000, and that will be 10 divided by 1,000 will be that. Now that is our roof live load. Now to change this one to member, you need to multiply by the center to center distance between the members, let's say by 25 feet. So this one multiplied by 25 should be equals to 0.25. So that is our dead load, and dead load acts in the local Y, so that the value is negative 0.25. Add, assign to view, yes. Okay. Let me edit that load. It was in the global Y negative, so that is okay. For roof live load will be 20, so this one will be add member point negative 0.5, 0.5, acting in the local. Add, assign the selected beam, assign, yes. We will now again add. We can add another load case for snow, roof snow load. Add member. Now this one is 30 divided by 1,000. The answer is 0.3 times 25, 0.03 times 25, 0.75 Now this one will be acting in the global, negative 0.75. Snow loads acts in the global y direction. Then assign to the selected beam, assign yes. I will review whole structure. Okay, now we can assign wind load, add wind, so if I go to wind load, it's like we have not defined our wind load, so can just delete, add, calculate as per ASSC. You can just fill in this data. My building height is 35. Apply. Then OK. Then my exposure is 1. Add. Assign to be okay. Now this one I will delete. Yes. Delete. Yes. Add. I will add wind load, add wind. So the problem is in this place. We can just first ignore this, delete, yes, and then save. I will close and then open again so that we can determine. Because we have wind definition, but we're not able to assign wind load. I'm not sure what is the problem, so let me check. I go to loadings. These are my load cases. Add. Okay, we have added intensity, so there was missing intensity, and then we delete again. Need to add. And then I will add my exposure of 1. The problem was missing intensity. Assign to view. Then if now I go to wind load, wind load X, add, wind load Z, add, wind. Now we can be able to add this one. So when y-axis is vertical, you can either select open structure or not, minimum range. You can see this wind, the generated wind load, add. Z, open structure, add, and you can see the generated wind load, and we can save. Yes, we can do automatic combinations, generate, then add. We can go to analysis command, add, no print. Then we can go to state design, so select parameters, define, and then commands, check code, add. We do not optimize. Remember, takeoff, add, takeoff, add. Assign to view, assign to view, assign to view. Then we can save. We can now run our analysis. Zero error, zero warning, one node done. So if I check my column, you can see the design. The design has passed. Design properties. You can be able to print using this option here. If I go to select by property, failed beams, you'll be able to see the failed beams, and you can change your sections, and also you can change, for example, you can see these bracings are failing. It means that you need either to check whether it's because of that release assigned, or we should assign release to our beams. So there's so many reasons why some member might and might not be failing, or we can assign release in our columns. So I can go to specify start, and then I want to select parallel beams parallel to X. Then I will assign that release. Yes, there is no moment between those numbers. And then parallel to Z. Okay. The next thing is to we can add some beam. Because this project is a very big one, I will not focus on passing all these members. These should be what you can try to do to find the solution, which are in my other videos. So thanks for watching. See you in the next video. You can just quickly check properties, failed beams. The failed beams are these, all these. So I go to properties, go to specify, and then let me first view selected objects. So we can continue in the next part. So thanks for watching. See you in the next video.